We've already covered the foundational concepts, so we're ready to add on the more complex questions that you're going to see towards the middle and end of each section. We're going to start off talking about plane geometry because out of this category, 7 points is a major component of your score. We're going to add on with coordinate geometry. We're going to talk about operations and what exactly that means. You're not going to be doing any appendectomies. And we're going to talk about logic and sequences before we move on to reading. Starting off with plane geometry, we want to know the math fundamentals that have to go with this particular concept. You don't want to skip over anything that is going to be an integral part of this particular topic. So one thing that you want to know, and this is an interesting thing, they don't actually talk about complementary angles, which add up to 90 degrees, but they most certainly talk about supplementary angles. Those always add up to 180 degrees, which gives you a straight line. And the reason why it does that is because if you draw it, you wind up with a half a circle. So for example, A and B are supplementary, so when you see that arc, that makes sense, it's a half of a circle. In terms of vertical angles, those are ones that are opposite, like A and C, and those have equal angle values. So if A, and that looks like an angle that's greater than 90 degrees, if A were, let's say, 110, then C would be 110 as well. So we're taking a look at how these all relate to each other. So if I switch over to another color, take a look how B and D match up. So if A and C are 110, then B and D have to be 70. So once you have information about one of the angles, when you have, this is what's called a transversal, you actually have a lot of information. Now, when we talk about corresponding acute and corresponding obtuse angles, I was saying how A is greater than 90 degrees, and the reason why I was looking at it and sort of tilted my head was because I can actually visually see that it's greater than 90 degrees. A 90-degree angle is a right angle, so if it were just straight up and down, then that would be 90. Because it's tilted to the right-hand side, then I know it's greater than 90, so that's 110. When we talk about corresponding angles, let me grab another color. Those would be angles like B and F. And F has to be 70 as well because those correspond to one another. Those are called acute angles because they're adorable. Of course not. It's because they are less than 90 degrees. So the corresponding angles, another group of corresponding angles would be C and G. So transversal actually winds up giving you a lot of information. Parallel lines, and that's how a transversal is made with two parallel lines and then a third line cutting through it. Those are noted with the symbol that looks like railroad tracks. And parallel lines always have the same slope, which actually means that they're never going to intersect. If you have perpendicular lines, you have 90-degree angles or right angles. The perpendicular lines, this idea of opposite reciprocal slope is something that you can think about. So if we have a slope, slope is often represented by M. If we have a slope of -2, a line that is perpendicular to that line would have a slope of +1/2. So when you take a look at the idea of opposite reciprocal, if the original is negative, then the opposite reciprocal is going to be positive. If the original is positive, the opposite reciprocal is going to be negative, but also don't forget to take that reciprocal. Another example would be -3/4. A line that's perpendicular to a line that has a slope of -3/4 would be +4/3. Another term you want to know is bisect. When you see that word bisect, like bicycle has 2 wheels, a bisected angle has 2 parts that are equal. Just like most bicycles have 2 wheels that are equal to each other, otherwise you'd be a little bit lopsided. When we talk about the sum of interior angles of a triangle, knowing that they add up to 180 degrees is going to be really helpful, and we're actually going to do a question. The area formula is always the same. Make sure you have that memorized. Unlike the SAT, the ACT does not include any formulas. They do not give you a formula sheet, so you can have it all in your head. External angle is equal to, okay, so read through this a moment, and I'll actually draw it for you. I was going to read it out loud, but you know what? Reading it out loud doesn't have any added benefit if you're not sure what I'm talking about. And I can actually demonstrate it here. So if I put an X right here, and this angle, I drew my triangle kind of small, but if I tell you that this angle is 70, and this angle is 60, then I can tell you for sure that X is equal to 130. And then the interior angle, the supplementary angle, I'll do a different color. We're getting a little smushed here. This right here has to be 50. So in the blue though, this is the idea of exterior angle. So if you have those other two angles, you can find the exterior angle, which in this case is 130. And you don't actually have to do it that way if you don't want to. You could also just find the missing angle and then do supplementary angles. When it comes to plane geometry, there's actually a bunch of different ways to find the correct answer. And students often ask, okay, well, but what's the best way? And this idea of best way when it comes to math has to do with what you're most comfortable with. So I can't tell you for sure what the best way for you is going to be because you're an individual and you want to use your strengths to your advantage. So let's remind ourselves of the recommended approach. You're always going to read the question and then you're going to identify the information provided. So the first two steps for every student are the same. But step number 3 is going to depend on you. You can pick numbers or back solve on over half of all the questions on test day. But whether or not you want to do it that way is totally up to you. So keep this in mind and you'll see this demonstrated a little bit more when we do a question. Now this next concept, the side opposite of greater angle is greater than the side opposite of smaller angle. Sides opposite equal angles are equal. And actually we can demonstrate that with another picture. Plane geometry oftentimes, and this is not going to be as helpful as this guy. Plane geometry oftentimes is easiest when you have a picture, so if they don't provide one for you, draw it out. So let's say that this angle is 70, and this side is 5, and this side is 5. We can know for sure that other green angle is also 70, and we can also know that this angle is 40 based on supplementary angles, and that this side, X, has to be smaller than 5. Because if looking at the green part, those are longer sides that correspond to bigger angles. And to take a look at the sort of opposite of that angle. So 5 is opposite of 70, the other 5 is also opposite of 70. So a side opposite of greater angle is greater than a side opposite of smaller angle, and that picture right there demonstrates that. A triangle with 2 equal sides and 2 corresponding equal angles, which is actually the one I just drew, is isosceles. And then we have equilateral triangles. Because a triangle adds up to 180 degrees, if all the angles are equal, divide it by 3 and you're going to get 7. Just kidding. You're going to get 60. So no matter what equilateral triangle you're looking at, no matter how big the sides happen to be, the angles are always going to be equal and the sides are always going to be equal to each other. So you may have an equilateral triangle with sides of 14. You'd have 14, 14, 14. Doesn't matter. If you had sides of 2, 2, and 2, you'd still have angles of 60, 60, and 60. The triangle inequality theorem also deserves a picture. And if we fill in the information, you can go ahead and read it to yourself and then take a look at what we're drawing here. So if we have 8 and we have 5. 8's the big guy, 5's over here, and then we don't know what X is. X can't be 40, and you can know that by just looking at the picture. There's no way. That's too long. But then again, what can X be? Are there any rules governing how big or small X can be? You better believe there are. X has to be somewhere in between these values. So if you take 8 minus 5, you're going to get 3. 8 plus 5 is going to give you 13. Has to be somewhere in between there. So you take the sides and you subtract them, and then you take the sides and you add them. And you have to have the other side somewhere in between. Otherwise, you're going to have something that's way too long or way too short. So they often ask you which of the following could be a value of X, and then you're going to get rid of anything that doesn't work. So if they gave you the numbers 3, 4, 5, and 6, 3, 4, 5, 6, and 7, because there are 5 answer choices, you would pick 3. 3 cannot be x. It has to be greater than the difference. It also can't be 13 or anything bigger than 13. In terms of similar triangles, they do like to draw them in a particular way that's a little bit confusing, but if you know what to look for and you practice ahead of time, you can get the points for this type of question. So what they usually do, rather than drawing 2 triangles side by side, they draw a big triangle and then put a smaller triangle in between. Now, because the smaller triangle is within the larger triangle, then you know that they have to be similar triangles because the angles are the same measure. This particular one that I drew, I'll go ahead and put in the symbol so you know that it's a right triangle as well. And then what you do is you set those up in a proportion if you're solving for one of the side measures. And this is a really common question. You want to know how to do this type of question because it often actually shows up around between questions 5 and 20. So it's towards the beginning of the section oftentimes. And you can usually get this question done in less than a minute. Basically what it usually looks like is they will have something like 5, 10, then they won't tell you what this side is, and they will tell you that this from here to here is 4. So the bigger side is going to be 10 over x plus 4 equals 5 over x. And then you could solve from there. So you just have to set it up into a proportion. So you have the leg of a triangle over the hypotenuse, leg of a triangle over the hypotenuse, cross multiply. If they included this type of question, it would be more towards question number 20. Sometimes they don't make it nearly as complicated. But in general, you want to be really comfortable with right triangles. They appear the most often, which is actually really great because right triangles have additional information just based on the fact that they're right triangles. The Pythagorean theorem can be used for every single right triangle you have ever seen in your life if you're provided enough information. So the Pythagorean theorem is only going to work if you have 2 of the side measures. If you have just one side measure, then you're actually going to be looking for something else. So one thing to keep in mind for the Pythagorean theorem is make sure you know which one is the hypotenuse, and that's going to be the longest side. If you have only one side measure of a right triangle, chances are it's actually a 30, 60, 90, or 45, 45, 90 question. If you have 2 side measures, use the Pythagorean theorem, but also look to see if there are multiples. And a lot of times it'll be something like 9 and 12, and they're going to be looking for the missing side. That missing side is going to be 15. So you can use the Pythagorean theorem, and some students are super fast at using the Pythagorean theorem, so go for it. But other students recognize that it's a triple, and the triples happen, you'll see them a couple times on the test, and you can use that to your advantage because you want to pick up time anywhere you can. With the harder questions, you want to have additional time. For Pythagorean theorem, those generally aren't the super, super hard questions. However, if you have a 45, 45, 90 or a 30, 60, 90 triangle, those are usually towards the end of the section. They're additionally complicated. And the reason is because you have to memorize the ratios. So they may tell you that you have a right angle and one of the angles is 30. The other angle has to be 60. Because when you take 180 minus 90 minus 30, you get 60. So if they tell you that the side measure across from 30 is 3, you have enough information to actually figure out everything else. So if you're looking at a right triangle and you have only one side measure, check to see if it's a 30, 60, 90 or 45, 45, 90. The side across from 60 would be 3 root 3, and the side across from 90 degrees would be 6. So you didn't have enough information for Pythagorean theorem because you only knew x equals 3, but you actually have enough information for everything else. One thing to keep in mind for 45, 45, 90 is that it's actually a square cut along the diagonal. So look out for word problems that have information about a garden that's a square and then it has a diagonal of 3 root 2. So how long would the fencing be for each side? So be on the lookout for that. They sometimes word it in a way that it indicates it's a 45, 45, 90, but they don't draw it for you and they don't actually come out and say that. When you are working with plane geometry, triangles do appear the most often, but they're not the only shapes on there. They could actually wind up drawing some really weird shapes, so this is my favorite to draw because I don't have to be too meticulous about it or too careful about it. So that is not what we call a regular pentagon, meaning all the sides are not equal, all the angles are not equal, and you can definitely tell because it's sort of a lopsided house. But I can tell you that the interior angles all add up to 540. And the reason is because we have 5 sides. And when you plug it into the formula in green, then you will find 540. So knowing that formula is really helpful. If they draw something out to you that's kind of smushed looking like mine is, it doesn't matter, count up the sides and plug it into the formula. Now, in terms of parallelograms, those can be drawn, actually what's interesting is they usually appear in the middle part of the test. And those are usually drawn, not misleadingly, but I'll show you what I mean by this. Okay, so they oftentimes draw this. Actually, they don't usually add in that part. Okay, it usually looks like this, and they'll say that this is 8 and this is 6. The area of that is not 48. That is a very common mistake, and I like that it shows up in the middle because it doesn't take you a ton of time to do, but it's really rewarding for you to know the track. So that's a parallelogram. The opposite sides are equal, the opposite angles are equal, but the area is base times height. So what you actually need to find is the up and down measure, and I can tell you right now it's not going to be as large as 6. The diagonal is going to be longer than the height because it's tilted. Now, if you're working inside of a parallelogram and you're working with angles inside, keep in mind that they intersect and bisect each other. Now, a trapezoid is not a parallelogram, so you can't use the same formula. The formula for a trapezoid instead is 1/2 height and then in parentheses base 1 plus base 2. That's kind of hard to remember, but actually what they're trying to show you, and I'll show you this guy. He's sort of upside down, which is not a problem. The formula works fine. Okay, so let's say this is 10, and this is, I'm gonna make it 8. And this up and down is, this is not drawn to scale, not because I'm trying to be misleading, but because I can't draw freehand. So what they want you to do is they want you to take the average of base 1, base 2, so the average of 10 and 8. Remember, average of base 1, base 2, and then multiply it by the height. Either way, as your points on that question, that's going to be really good. Trapezoids only appear once, if that, on the test, but you want to be prepared. So grab that point by memorizing the formula any way you want to memorize it. Just make sure you get it in your head. For regular hexagons, they have the same length side. So if one of the sides is 4, the rest, all of them are 4. And the interior angles look like the picture right there. And that's going to be helpful because, take a look at this. Remember how I said that a square cut along the diagonal is a 45, 45, 90 right triangle? An equilateral cut along the middle, bisected, so 2 equal pieces, winds up giving you a 30, 60, 90 right triangle. So keep that in mind. They may describe a word problem or they may have a picture that indicates that. Now we're ready to try out a question. And I had mentioned that knowing that the interior angles of any triangle equal 180 is going to come in handy. So what they have here is, in the figure above, what is the value of D? So be very careful not to put in the value of A. We need the value of D. And you want to use the power of your pencil. So make sure you indicate what angle you're solving for. So if you're solving for D, we need to figure out what additional information we have. That symbol means that this is 90 degrees. So if you think about this being A plus 20, so let me use blue. So a plus 20, that one, plus d up here, plus 90 is equal to 180. That's all its own triangle. Okay, but that doesn't help us so much right this second because there are two variables and only one equation, so we can't solve. So what else do we have? Well, we have a plus 2a plus 90, so the other side over here also is 90. Sorry for the squiggly. Then you can solve for the value of a. So do your math here, and a is 30. Answer choice A, we're all done, right? Well, take a look at our recommended method. Make sure you answer the specific question asked. So what some students find is really valuable is actually circling in the question stem what you're supposed to be finding. We're not looking for the value of a. We need it to find what we're looking for, but that's not our final answer. So this would appear around question 40, 45, because it's additionally complicated, but it's not inaccessible, meaning, yeah, it's got a few extra steps, but you can totally do this math and get your points. So if a is 30, then we can plug that information into our equation that we wrote down originally. So we have first combine the 20 and the 90s to just simplify it, then subtract on both sides. A plus d equals 70, but we already figured out that a equals 30. Now all the steps written out in blue, if you did it slightly differently, but you still found that d is equal to 40, that's totally fine. This is just the way that we wrote it out because that's how it worked out in our mind. And by our, I actually kind of mean mine when I animated this slide. It's just the way it flowed for me, but as long as you find that d is 40, you get your points. Do not fall into the trap of a equals 30. So overall, plane geometry is a lot of memorizing formulas and actually repetition. If you can figure out the types of questions you know really well, you can do just a couple of those and move on. If you have questions you know that you need additional practice with, now's the time to practice, not the night before. So the night before a test, you should be resting and just thinking about everything you already know. You should not be cramming information. For coordinate geometry, it's very similar to plane geometry in that there are a lot of formulas to memorize. So if you want to make flashcards, if you want to say them out loud, if you want to tell your cat or your dog, anything you can do to memorize them, it's invaluable information. You're not going to be able to find it anywhere else. It's going to be in your head on test day. So you're going to memorize y equals mx plus b is the standard equation of a line. M is the slope, and you can think about it as either rise over run, or you can think about it as the change in y over the change in x. But no matter how you think about it, you are going to have to know the formula of y2 minus y1 over x2 minus x1 will give you the slope. And we'll actually show you a question with that. The idea of, okay, what's the slope? What do I do? How do I plug it in? We're going to do that in a minute. Now, in terms of the y-intercept, that's the b, and that's where it crosses the y-axis. Now, if you wanted to solve for the x-intercept, then you would have to have all the other pieces of information in place, and then you would have to have y equals 0. When a line crosses the x-axis, the y value is 0. Doesn't come up very often, but we just want you to know that when you look at the standard equation of a line, you have the y-intercept and you can solve for the x-intercept, but the b does not stand for the x-intercept. It only stands for the y-intercept. Now, in terms of slopes of lines, generally positive and negative slopes are pretty straightforward. So n is positive, L is negative. A lot of students can pick that out on a graph without too much trouble. The idea of a zero slope and an undefined slope is a little bit harder, but one thing that I like to think about is that I really, really would prefer to run on a treadmill with a zero slope rather than a positive or a negative slope, but most certainly not an undefined slope. So if I'm on a treadmill, I want to be going on zero slope because, so take a look, K would be 0. Undefined, I would be clawing my way up that treadmill. That sounds terrible. So if you want to think about that as zero slope as just being completely flat, very easy to run on, and then undefined being the opposite of that. However you can memorize it's going to be helpful because you're going to see it at least once on the test. Parallel lines have identical slopes and perpendicular lines have opposite reciprocal slopes. We talked about that in plane geometry, but it comes up again in coordinate geometry. They may ask about midpoint. If they do, you'll see it maybe once or twice. The midpoint formula is actually the average of the x values and the average of the y values of 2 points. So that's a good way to think of it if you're working on memorizing the formula. For the distance formula, it's actually a variant of the Pythagorean theorem, but no matter how you think about it, you do need to memorize it. So you could actually draw it out if you wanted to and then make a triangle, but that seems like a lot of extra work. And again, you want to rack up as much time as possible to spend on the harder questions. So memorizing the midpoint formula and distance formula, if you haven't done so already, is on your list of things to do. When it comes to parabolas, those look different than standard equation of lines. And one of the things you can look for differentiation among the two is the idea of an exponent. So if you see x squared, then you know you're going to be working with a parabola. If you want to reverse FOIL, make sure you set it equal to 0 before you start factoring or reverse FOILing. Most of them have two solutions, especially on the ACT, and those are considered x-intercepts, roots, or zeros. You can call them any of the following, and you'll be able to follow along on test day. For classic quadratics, knowing that x squared minus y squared actually originally looked like x plus y times x minus y is helpful because that's a difference of squares. So those types of questions come up, and actually when you're working on Grokkit, you can set custom practice to practice these particular types of questions. So if you're not exactly sure what you're going to see for this type of question, just go on Grokkit, click on custom practice, and then pick out ACT math and the subject that you want. And that way you can see, okay, I kind of get this, but what is it going to look like? You really want practice on this type of question because they don't have many different variations of how to present this information. So if you just work through a couple of them, get a really good idea of what they're going to be asking. So the classic quadratics are right there. There's only 3 classic quadratics, and they don't get much fancier than that. As I mentioned, it does graph as a parabola, and one of the easiest things to check in terms of answer choices, if they have pictures for answer choices, if A is positive, then it opens up like a smiley face, and if it's negative, it's very sad. It's a frowning face. So if you are looking to eliminate some answer choices, and you see that some of them are smiley faces and some of them are frowning faces, then you can actually get rid of them based on the equation that they present to you. So now that we've talked about coordinate geometry, we don't want to leave you and move right on to the next topic, which is going to be operations. Instead, we want to pause and take a look at a really common question. So they tell us, what is the y-intercept of a line that has the slope of x and crosses the x-axis at x equals 7? So here we don't need the slope formula, but if we did, it would be y2 minus y1 over x2 minus x1. Instead, they actually give us the slope. So let's plug that in. Y equals mx plus b winds up being y equals negative 4x plus b. Then we have an x value, but where did the 0 come from? It crosses the x-axis at 7, and as I mentioned before, the x-intercept, which is what they're giving us, at that point, the y value is 0. So for the x-intercept, the y value is 0, and then the x value is whatever it happens to be for the line. We plug that in, and we can solve for b. So we wind up with b equals 28, answer choice E. So this is a really common question. Go ahead and back up the video and review this again so that you can make sure you recognize, okay, they gave us the slope, we plugged into the standard equation of a line, but where did the 0 come from? Make sure you're thinking in your mind, okay, when it's crossing the x-axis, the y value has to be 0 because it's sitting right on the line. It's not going up or down in any direction. So for coordinate geometry and plane geometry, look at the formulas that you need to memorize, put those in your head, and practice questions. For operations, these, again, don't include any appendectomies. You don't have to take out any tonsils. What these are radicals and exponents, and we're going to look at logarithms. So when you are multiplying two exponents and they have the same base, then you add the exponents. When you are dividing exponents with the same base, you subtract. When you have different bases but the same exponent, then you actually multiply. And then when you raise something to another exponent, then in that case, you do multiply. When you have a negative exponent, you're taking the reciprocal of that number. So you have 1 over 4 to the 3, and actually let me add on, because that is a good example, but we also want to do this one for you. So it winds up being 4 over 3 to the positive 2 on the top and the bottom. So you get 16 over 9. So in the example given, they give you a whole number, but I wanted to add on the example of 3/4 to the negative 2, just so you know that you flip it and then you raise both top and bottom to the exponent. So technically, and I'll add it in here. It's just that since it was the number 1, it wasn't added in. But technically, it's 1 to the 3 as well. We didn't want to leave that out because that could be misleading if you were memorizing it. Okay, for fractional exponents, those are roots. And the part that's missing here, it's not actually missing. Anything I'm adding isn't missing. It's just additional notation for you. A square root technically has an invisible little 2 right there. So if you had, so this will give you the number 8. So if you had 8 to the 2 over 3, you would have this. 3, 8 squared. 364. 4s are really hard to write. And then you would have that would equal 4. So there's another example too for that one. Anything raised to the 0 is the number 1. I would say anything at all, including an elephant, which technically wouldn't show up on the ACT and probably, I guess, mathematically isn't true, but just remember anything raised to the 0 is equal to 1. If you are talking about the square root of a number, it has to be a positive number, but if you have something that was squared or raised to the 2, it could have been negative to begin with. So it could have been 9 or negative 9 if it's equal to 81. However, square roots are always positive. So keep that in mind. That will come up in the more complex questions towards the end of the section. When you are taking the square root of a fraction, just make sure you do the top and the bottom, and you can do them separately. And then in terms of reducing radicals, you can do a factor tree, or you can split them up into smaller pieces. So if you wanted to do a factor tree of 75, and this is a personal preference situation. So 25, and then 3, and then you have 5 and 5. So then you have 5 root 3. Either way is fine. So either look for perfect squares or you can do a factor tree. Doesn't matter which way you do it, as long as you can get through it pretty quickly and move along to find the correct answer. For imaginary numbers, these do not show up on the SAT, but they are on the ACT. The good news is that you just have to memorize the idea of the square root of -1 equaling I, because everything else makes sense from there. So if you can just remember I is equal to the square root of -1, you can figure out everything else. And in addition, you want to keep in mind that it's a pattern. So I corresponds to I to the 5 and I to the 11. Wait, no, not I to the 11. And I to the 9. So it goes in order. So you want to think about if you had, I'm trying to explain it without drawing it out, which is just a terrible idea. So if you had I to the 40, it is a pattern. So you can take 40 and divide it by 4, and you get 10, remainder 0. So I to the 40 I know has to equal 1, because if you get a remainder of 1, then, or you can think of it as 10.0 if you get a remainder of 0. If you get a remainder of 2, or if you get a remainder of 3, or when you divide, so if you take 7 divided by 4, you get 1.75. So 0.75 would be here, 0.0 would be here. Let me move some of this stuff out of our way. So I to the 40 is equal to 1. There you go. So this one is 0.25. And this one is 0.5. or remainder 1, remainder 2, remainder 3, and remainder 0. So no matter what number you have, so you could do I to the 25. To the 25. And that is going to be equal to I. Because you take 25 divided by 4, and you're going to wind up with 6.25. And since it corresponds to 0.25, then you're going to get I. If you think about I to the 18, that's going to be equal to -1. So it's all a pattern. So you can watch this part again. You can see me go through it again. The idea of you can either use remainders or you can use the 0.25, 0.5, 0.75, 0.0. What we're trying to demonstrate is that it just goes in order. And it's all built on this idea that I is equal to the square root of -1. Now for logarithms, basically it's a shortcut to exponents. So for multiplication, it's a shortcut to addition. Logarithms are a shortcut to multiplication. So it's just a rearranging of how to write things. So take a look at this question. We want to know what x is. When you rearrange everything, you just wind up with this. So it's written differently. It looks really strange if you've never seen it before, but they just want you to move everything around and you'll be able to figure out what they're trying to ask. They just want to know in terms of exponent form what that would equal, and that would equal either +8 or -8. Oh, and actually, they would never have both options available. So if you ever have an answer that could be either positive or negative, so let's say you're working with absolute value or you're working with roots, let's say they ask for one value of the root, then you don't have to worry. They're never going to trick you with whether it's going to be positive or negative. They're only going to give one option available. So correct answer, answer choice B. This is only going to show up maybe once. So when you think about what to study first, coordinate geometry, plane geometry, together that's 13 points. Operations, 3 points. So make sure you're using your studying time wisely. Now our final concept is worth 2 points. Logic and sequences. For logic, there's nothing to memorize. You just want to keep in mind the difference between 2- and 3-dimensional objects, and also think about moving through things step by step. So for this particular question, you can do it a couple different ways. If you wanted to back solve, it says what is the greatest number of pieces? So you'd start at answer choice E and figure out if you can get 8 pieces. If you wanted to just visualize it, you could think about a cube, so like a block of chocolate, let's say, and you've got hungry children, or probably not hungry for chocolate, but children who want a treat, and you want to break it up into as many pieces as possible. You've got a whole bunch of kids asking for a piece of chocolate. So if you make 3 cuts, let's say you make it across the top first, you wind up with 2 pieces, and then you wind up with 4 pieces. At this point, you can draw a diagonal here, and you'd wind up with 6 pieces, which is answer choice D, but because it's 3-dimensional, you could actually do this instead, and you wind up with 8 pieces. There's no actual formula for this. It's just a logic question, and they ask different types of logic questions. One thing to note is that you can always skip over a question and then come back to it later. So for this question, if it doesn't jump out at you right away as, oh, I just cut here and then cut here, all done, you can put in your letter of the day and then move on, and then come back to it if you have additional time.